So now let's take a look at the benefits of high pressure gas lifts.
So the first benefit of high pressure gas lift is that you can reach a deeper injection point for your gas lift in your well. So if you are familiar with gas lift, you already know that the deeper you inject your gas lift, the higher your production will be. I just took these two illustrations from my unloading sequence showed in the previous video to illustrate that. As you can see, when you inject your gas lift across your first mandrel, you have the following pressure profile in your well and this drawdown applied, while if you inject gas lift across your fourth gas lift mandrel, you have this pressure profile in your tubing and a much larger drawdown applied on your reservoir, hence a higher production. This is because by injecting the gas lift across that point, you can lighten the fluid in all this portion of the tubing, which is then a much larger portion than when you only inject it across the first mandrel. This is why you can get a higher production using HPGL if it allows you to reach a deeper injection point in your well. So if we take a look at these two examples over there, we can see that in this well, if I have a conventional gas lift network pressure, I might not be able to inject gas lifts below that third gas lift mandrel over there, while with high pressure gas lifts, I might be able to inject my gas lifts through my lowest injection points. And hence, when I have high pressure gas lifts in such a well, it will allow me to apply a higher drawdown on the reservoir and hence to produce more. So this is the first benefit of high pressure gas lift. It is to produce more by injecting your gas lifts through a deeper points in your well than what you would have been able to reach using conventional gas lift network pressure. Next benefit of high pressure gas lifts, it allows to reduce the number of gas lift mandrel needed for the unloading sequence of a well. So that's what we could see in our example at the beginning. Without high pressure gas lifts, we needed to have 4 gas lift mandrels in the well, while with high pressure gas lift, we only needed the bottom 2. So high pressure gas lift simplifies and reduces the cost of completion. So in this example over there with conventional gas lift network pressure, I need 7 gas lift mandrels in my well, while with high pressure gas lifts, I will be able to fully unload my well and inject gas lift across my lowest mandrel only with 3 gas lift mandrels in total. As you reduce the number of gas lift mandrel needed for your unloading sequence, then you reduce or eliminate with single point gas lifts, you reduce or eliminate the risk of multi-pointing gas lifts. So I made that slide to illustrate what is multi-pointing gas lift. So as mentioned, your unloading valves, they have an opening and a closing pressure. And what can happen is that sometimes your casing pressure stabilizes at a value where you have several valves which are open at the same time. So in this case, we can see that the casing pressure is too low to inject gas lift across your orifice, but it is high enough to inject gas lift in any of these 3 valves. And as the casing pressure has stabilized at a rather high value, we can see that the casing pressure is still higher than the closing pressure of the first, the second, and the third valves. Hence, these 3 valves are open and gas lift can be injected across the 3 of them at the same time. And so this is what we call then multi-pointing, and obviously this is a lot less efficient to have some of the gas injected across the first and the second valve than having all of it injected across the third one. So that's what we call multi-pointing. So in the SPE paper which is quoted over there, we have an example of the reduction of the amount of gas lift mandrel needed to complete the unloading sequence of a well based on the gas lift network pressure available. And we can see that in the well that they had selected with 1000 psi of gas lift network pressure, they need 10 unloading valves in the well in order to transfer the gas lift from the surface to the lowest mandrel. While if you increase the gas lift network pressure to, let's say, 1700 psi, in that case, they only need 3 gas lift valves to transfer the gas lift injection from the top to the bottom. And at 3700 psi, they can operate the well as a single point gas lift well, so they only need the orifice installed in the lowest mandrel. So again, this is the second benefit of high pressure gas lift. It reduces the amount of gas lift mandrel needed for the unloading sequence of a well, and so you can reduce your completion costs and your risk of multi-pointing gas lift.
And so these are the two main benefits of high pressure gas lifts: reducing the amount of valve for the unloading sequence of your well and having the ability to inject gas lift through a deeper point in your well. And so in both cases, it helps to simplify the operating of your well and maximize its production.